Welcome back to G Fun Facts Online. Today, we are not just talking about facts, we are talking about the invisible engine that keeps the modern world running, and how it is about to undergo a transformation so radical, it makes the switch from steam engines to diesel look like a minor software update. We are diving deep into the intersection of quantum physics and global logistics. Now, when you think of the supply chain, you probably picture massive container ships, endless fleets of trucks, and cargo planes crossing the Atlantic. It feels physical. It feels tangible. But if you peel back the skin of that industry, what you find underneath is a math problem. A math problem so brutally complex that our current best supercomputers are hitting a wall. This is the story of how we are breaking that wall. The global supply chain is a living, breathing organism of unimaginable complexity. Every single second, millions of shipping containers, delivery trucks, and last-mile couriers are moving across the planet. For decades, we have relied on classical computing to tame this chaos. We use algorithms to predict demand, route fleets, and manage inventory. But classical computers operate on binary logic, the ones and zeros we all know. And the mathematics of global trade, with its infinite variables of weather, traffic, geopolitical strife, and shifting consumer demand, has become too heavy for that binary logic. We are leaving efficiency on the table, billions of dollars of it, simply because our computers cannot calculate the full picture. Enter quantum optimization. This is the new physics of supply chain efficiency. To understand why this matters, we first have to appreciate the crisis we are currently in. Logistics, at its core, is what mathematicians call a combinatorial optimization problem. Let me visualize this for you. Imagine a single delivery truck in London with 10 packages to deliver. To find the absolute best route, the one that saves the most gas and time, you have to calculate every possible order of stops. For 10 stops, there are over 3 million possible combinations. A classical computer can solve that in a blink, but now imagine a fleet of 50 trucks delivering 1,000 packages. The number of possible combinations for that fleet exceeds the number of atoms in the observable universe. This is what is known as the nitrogen monophosphide hard problem barrier. Current software literally cannot find the best solution. It uses heuristics, which are basically shortcuts or best guesses. It slices the problem into small chunks, optimizing one truck or one district at a time. The result is a patchwork of local efficiencies that misses the global optimum. But the world isn't stable. A strike in a German port or a hurricane in the Atlantic ripples through the network instantly. Classical computers are too slow to re-optimize a global network in real time. This is where the quantum engine comes in. You don't need a PhD to understand this, but you do need to grasp one key difference. Classical computers use bits, which are switches that are either on or off. To solve a maze, a classical computer tries one path, hits a wall, goes back, and tries another. It is sequential. Quantum computers use qubits. Thanks to a property called superposition, a qubit can exist in a state of being both 0 and 1 simultaneously. If you link 50 qubits together, you can represent a number of states so vast, it is hard to comprehend. This allows the quantum computer to walk every path of the maze at the same time. It explores the entire landscape of possibilities simultaneously to find the true optimum. In the logistics world, we are seeing the rise of a specific type of machine called the quantum annealer. Think of an optimization problem as a landscape of hills and valleys. The deepest valley represents the lowest cost or the most efficient route. A classical computer is like a hiker walking blindly in the fog. It finds a small valley and thinks it is at the bottom, not realizing there is a deeper, better valley just over the next hill. A quantum annealer uses a phenomenon called quantum tunneling. Instead of climbing over the hill, the system tunnels through the barrier. It naturally settles into the lowest energy state, the optimal solution, much like a ball rolling to the bottom of a bowl, but a bowl that exists in multiple dimensions. This is the killer app for logistics. Let's look at the traveling salesman problem, the heartbeat of delivery routing. How do we map a delivery truck to quantum physics? We use a formulation called QUBO. We create a grid of qubits where we program the energy of the system to correspond to the total distance traveled. The computer naturally wants to minimize energy, which means minimizing distance. We add penalties for breaking rules, like visiting a city twice. In 2019, Volkswagen proved this works in a pilot project in Lisbon. They used a D-Wave quantum annealer to optimize bus routes in real time. Unlike classical GPS, which sends every driver to the same fastest highway, causing a traffic jam, the quantum algorithm acted as a collective brain. It anticipated that if bus A took the highway, traffic would increase, so it routed bus B through a secondary road. It optimized the flow of the entire system, not just the individual unit. Now, let's take this to the urban battlefield. The last mile accounts for over 50% of total shipping costs. Here we face the vehicle routing problem. It is not just about distance. You have time windows, vehicle capacities, driver shifts, and battery constraints for electric vehicles. Classical algorithms often lock a route early in the day. If it starts raining or a customer cancels, the schedule falls apart. Quantum hybrid solvers allow for dynamic re-optimization. Imagine a courier fleet in Tokyo. Rain slows down traffic in Shinjuku, but not Shibuya. 3 rush orders come in. A quantum solver can recalculate the entire fleet's schedule in seconds, perhaps instructing driver A to hand off a package to driver B at a meetup point to save an hour of deadlock. DHL is even looking at the bin packing problem. How do you fit 3D boxes of varying shapes into a container to minimize wasted air? By treating empty space as high energy, quantum algorithms can design packing configurations that human planners would never visualize, potentially increasing container utilization by 5%. In this industry, 5% is pure profit. Moving from the city to the sea, we encounter the maritime giants. A modern ship carries 24,000 containers. When it arrives at a port like Los Angeles, we face the berthing allocation problem. It is a scheduling nightmare involving tides, tugboats, and cranes. Ports are exploring quantum solvers to create fluid schedules that adjust crane allocations across the terminal instantly. If a crane breaks, the system reshuffles 10,000 priorities to ensure the ship still leaves on time. Then there is the yard stacking problem, which is essentially quantum Tetris. If you stack a container that leaves tomorrow underneath 4 containers that leave next week, you have to move 5 boxes to get one. These rehandles cost fuel and time. Quantum algorithms predict the retrieval time of every box and organize the stack to minimize future moves, reducing rehandles by up to 20%. In the air, companies like ExxonMobil are using similar principles to optimize routing by simulating global wind patterns and jet streams simultaneously. This could enable free flight concepts, where planes fly dynamic, optimized trajectories, rather than fixed highways in the sky. This brings us to a critical point: sustainability. This technology is not just about speed, it is about the green quantum. The equation is simple. Better routing means fewer miles driven. Reports suggest that continuous quantum route optimization could reduce fleet emissions by up to 20%. For a global giant like FedEx or UPS, that is hundreds of millions of gallons of fuel. Furthermore, quantum computers are being used to simulate battery chemistry at the atomic level, hunting for the next generation of materials that will make electric trucking viable. But we cannot discuss this technology without talking about the geopolitical chessboard. Supply chains are matters of national security. We are in a race for tech sovereignty. The United States is leading in gate-based innovations. China is investing heavily in state-driven infrastructure and quantum communications. Europe is fighting for tech sovereignty to avoid reliance on foreign powers. Ironically, the supply chain for quantum computers is itself fragile. These machines require dilution refrigerators that cool chips to near absolute zero. The helium-3 isotope needed for this is rare and primarily sourced from nuclear warhead decay, creating a strange link between nuclear disarmament and logistics optimization. There is also a security threat. A sufficiently powerful quantum computer could theoretically crack RSA encryption, the lock protecting global trade documents. If a hacker decodes the digital bill of lading for a supertanker, they could steal the cargo. The solution is quantum key distribution, or QKD. QKD uses the laws of physics to create an unhackable key. It sends data via photons. If a hacker tries to intercept the photon, the act of observing it changes its state, alerting the system instantly. We are looking toward a future where trade lanes between major ports like Shanghai and Rotterdam are encrypted not with math, but with physics. So what is the road ahead? Right now, between 2025 and 2027, we are in the era of hybrid solvers. Companies are cleaning their data and running pilots. By 2028 to 2032, we will enter the era of quantum advantage, where hardware stabilizes and universal logistics solvers handle full global networks in a single run. By 2035, we could see the autonomous supply chain. This is the convergence of quantum computing, AI, and 6G. A world where a shipping container negotiates its own route, and port terminals are dark, automated ballets, moved by a quantum brain. The supply chain will become anti-fragile, getting stronger the more volatility it encounters. Quantum optimization is not just about shaving a percent off fuel costs. It is about unlocking a level of visibility and control that has been mathematically impossible until now. It transforms the supply chain from a reactive chain of disasters into a predictive, fluid ecosystem. For the logistics industry, the quantum clock is ticking. The companies that learn to speak the language of qubits today will be the ones defining the trade routes of tomorrow. Thanks for listening to G Fun Facts Online. If you enjoyed this deep dive, stay tuned for our next episode.